In lesson 29, we're looking at uniform motion problems where you add two distances together to get a total distance. In our first example, Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on a caisson. He walked at 3 miles per hour and rode at 9 miles per hour. If the total time of the trip was 8 hours, for how long did he walk? Alright, so what we have are two rates, times, and distances. And if you want to think about it in the terms of maybe a picture, see this first leg of the trip, he was walking, and then the second leg he was riding, but the total trip is still going to be the 60 miles. Oops, there we go. Alright, so we'll have the rate, time, and distance for walking, the rate, time, and distance for riding. And when he was walking at 3 miles per hour. And when he was riding at 9 miles per hour. And then for the times. Now, one of the times we just assign as t, because they give us the total time. What we'll do is subtract the t from that total time they give us. And the total time was 8 hours, so we just subtract that. And now to get his distance walking, I would multiply the 3 times the 8 minus t, and the 9 times the t. Now I know when I add those two distances together, I would get 60 miles. So that's what we're going to do. 3 times 8 minus t plus 9t equals 60. Then I'll distribute my 3, so I'll have 24 minus 3t plus 9t equals 60. Combine the like terms, that gives me 6t. I'm going to subtract 24, and that'll give me 36, and then I'll just divide both sides by 6. So our time is 6 hours, and that was the time he was riding. Now I go back to what it asked for in the problem. For how long did he walk? So I've got the riding time, so I need to subtract that from 8 to get the walking time. So 8 minus 6 equals 2. So it was 2 hours walking. Now we could have assigned the time t to walking, and then when we solved this we would have gotten that time in the beginning. But either way you'll end up with the right answer. Just pay attention to which one you solved for. And then on our second example, we have Edward Longshanks and Queen Eleanor were 54 miles apart at dawn. Edward began the journey to the meeting place at 8 a.m. at 3 miles per hour. 2 hours later, the Queen set out to meet him. If they met at 4 p.m., how fast did the Queen travel? So again, we have two different rate, time, and distances, and two different parts that will add up to give us a total amount of miles or distance. Now this time they add up to 54, and we have Edward's, and then we have the Queen's. And so for our rate, time, and distance, one will be a subnotation of E for Edward, and then rate, time, and distance. One will be a subnotation of Q for the Queen. Alright, Edward's rate was 3 miles per hour. So that's going to go right here. And then for the queen, we don't know how fast the queen went. That's actually what we want to find, so I'm just going to put R. Alright, we know that Edward started at 8 a.m. and met the queen at 4 p.m. So if we count up the hours from 8 a.m. to 4 p.m. with 8, 9, 10, 11, 12, 1, 2, 3, 4. That's 8 hours. Now the queen started 2 hours later, so we just simply subtract that 2 hours from 8 hours, and that's going to give us 6 hours for the queen's time. And then to get the distances, for Edward's distance, all I need to do is multiply the 3 and 8, which is 24, and that'll be miles. And for the queens, I'll have 6R, because rate times time equals distance. And I'm going to add those together, the 24 plus the 6R, and that is going to equal 54, because I know that was the total distance, because they were traveling to meet each other, and they were 54 miles apart. So I'm going to subtract the 24 to simply solve our equation we've set up, and divide both sides by 6. So her rate was 5 miles per hour. So she's going a little bit faster than Edward. Alright, our last example, example 3, says, at noon, Rocket Man whizzed off towards Rocket Land. 1 hour later, Moonfa whizzed off in the opposite direction at a speed of 200 kilometers per hour, less than, that should be then, that of Rocket Man. If they were 11,800 kilometers apart at 5 p.m., how fast did each travel? Alright, so what we have again is a total distance. This time they're going in opposite directions. We can say one side is the Rocket Man, and we can say the other side is Moonfa. Okay, and we know their total distance that they're apart is 11,800 kilometers. So we're going to have rate, time, and distance for both of them. So one's going to be for Rocket Man, so I'm going to do a subnotation of R, and the other is for Moonfa, so we're going to just give him an M subnotation. Alright, so let's see what they tell us. I mean, you have to reread these word problems over and over and then pick out the important information and put it where you need it. So let's see, the Rocket Man whizzed off towards Rocket Land. 1 hour later, Moonfa whizzed off in the opposite direction at a speed of 200 kilometers per hour, less than that of Rocket Man. So if he's R, for his rate, his would be R minus 200, because it was 200 kilometers per hour less than, that should have H in there. Okay, and if Rocket Man started at noon and they were this far apart at 5 p.m., then he's been traveling at for 5 hours. And then if Moonfa started an hour later, he's only going to have 4 hours. And then we simply multiply our rate times our time, so we got 5R, and then we've got 4 times R minus 200. And what we're going to do is add those two distances to equal our total distance. So we'll have 5R plus 4 times R minus 200 equals 11,800. Alright, then we'll need to solve this equation that we've set up here. So distribute the 4, so 4R minus 800 equals 11,800. combine our like terms, which is 9r, and then add the 800. So it cancels here, but on the other side we're going to have 0, 0, 6, carried 1. 12,600 equals 9r. And then all we need to do is divide both sides by 9. So r equals 1,400. Alright, so we need to look back. How fast did each travel? So we have how fast Rocket Man traveled. Rocket Man was 1,400 kilometers per hour. And Moonfa, we need to subtract the 200 from that because, see, we just put that r right in here, and that would be 1,200 kilometers per hour. And so we've solved this word problem about Rocket Man and Moonfa.